Okay, here's another law of sines problem. This one is side, side, angle. We know that it's law of sines because we see that we have side A and angle A. Okay, you need to have one pair that matches. This is going to be the ambiguous case though because we have one angle. We need to find the other two, and that one angle is an acute angle. So this is where you could end up with 0, 1, or 2 triangles, and you just have to work out the math to see which it's going to be. Alright, so we need to figure out either angle B or angle C. So let's go ahead and go for angle B. So I'm trying to find angle B, so I'm going to put that on top. So I'm going to use sine B over B equals sine A over A, because A is the one that I have information for. So I'm looking for B. Little b is 18.9. We have A, that's 31.1. And little a is 11.2. So again, we're going to multiply by the denominator, multiply by that 18.9 to get that to the other side. So we've got sine B is equal to this whole thing. Sine of 31.1. Make sure that you close those parentheses before you multiply in your calculator by 18.9 over 11.2. Now you can put that in and hit enter and then do sine inverse, or you can do sine inverse of the entire thing, but you want to try to not round this. Okay, so we're going to have to do a sine inverse to get angle B. And when we do that, we get that B is equal to 60.6. Okay, now remember that sine inverse is going to return for a positive angle, which these are going to be. Sine is going to return only your first quadrant value. There could be other values that would work in sine. So we have to ask ourselves, is there another value? Sorry, I accidentally hit. Is there another value that would work for this? And the answer is maybe. So this is our first quadrant value. We've got a second quadrant value that's also positive. So this is our B1. And we have another candidate that would be 180 minus 60.6. And that's going to be 119.4. Okay, so that's another, if you put that into this equation, into the sine B, it's also going to work out. So we have potentially two triangles that fit this initial information. One where a triangle has 60.6 as the angle, and another one that has 119.4 as the angle. So we just need to figure out both of these and see if we actually do have two triangles. Okay, so for our B1 scenario, that's 60.6. We should be able to find angle C that goes with that. So we'll call that C1. So that's our first triangle that all goes together. So C1 is going to be 180 minus 60.6 minus 31.1. Okay, finding the missing angle in the triangle. And that's going to be 88.1 for our C1. And then we've got to find side C that goes with this. So we'll call that little C1. So I'm looking for little c1. So I'm going to use A and A like I did before, and I've got little c1 and sine c1. So let's plug in what we have. We're looking for c1. We know that angle c1, we just found that, is 88.1. My sine in there. Side A is 11.2 and angle A is 31.1. Okay, so we get all of that into our sine, law of sines equation. And again, we multiply by the denominator. Okay, we see that same step every time. If I forget to put the parentheses around that, just remember that they need to go in your calculator. Okay, so that's just a matter of putting that all in the calculator, and we get that little c1 is 5.78. Okay, so there's one possible triangle where we've got B1 goes with this, 60.6, C1, these are angles, is 88.1, and little c1 is 5.78. Oops, I did not mean to do that. Hold on one second. Okay, I had to pause there for a second because I had these numbers worked out ahead of time, but I realized that my answer didn't make sense. So here's angle C, and here's side C. If angle C is my biggest angle, then side C should be my biggest side. Hopefully that makes sense just from a graphic point of view. So I was looking here, and C1 is my biggest angle, but little c1 is not my biggest side. So I knew I had to have put something in the calculator wrong right here, and I did. This should actually come out to be 21.7. Side C should be 21.7. Okay, so we all make mistakes. That's one way that you can kind of catch and make sure your largest side should be across from your largest angle, and your smallest side should be across from your smallest angle. Okay. All right, so now let's go on to C2. Now that we fixed that, fortunately before we got too far, I'm going to fit that in right here. Okay, so C2 goes with B2, and I just deleted that, but B2 was 119.4. Okay, we found that in what I just erased there. You can always back up since this is a video. And we are going to look for C2. Okay, that's the missing angle. Now we've got the other two angles of the triangle, so we should be able to find C2. So we do 180 minus 119.4 minus 31.1, and we get 29.5. Okay, so we do in fact have a second triangle. If we had gotten a negative here, that can't happen, and that would mean that there is no B2 scenario. You would cross this out and there'd be one solution. Okay, so you have to kind of use your judgment as you go. You can't just keep chugging along. But we do have another triangle. Okay, we've got our A, B, and C angles, and now we need to find our little C2 the same way that we found our little C1. So C2 over sine C2 equals A over sine A. Okay, so, sorry, we're going to multiply both sides by, oh, now let me plug them in. That's what I was doing. Okay, so C2 over sine 119.4 and little a over sine A. There we go. Now we can multiply by sine 119.4, sine 119.4. Okay, so we plug all of that in the calculator. Hopefully I got this one right, and I get 10.6. Okay, so our second scenario is B2 is 119.4. C2 is 29.5 degrees, and little c2 is 10.6. Okay, so that's the case where you have two complete triangles. Okay, so either one of those sets of information would make a triangle that works.